So sound you heard through your ear, but when you differ the sounds, like sometimes you say that you heard very big sound. Generally use big word, but big is not correct word. You can say louder sound. Sometimes we say that I heard very high pitch sound. So how do you differing the sounds with loudness and pitch? And those are nothing but the characteristics of sound. So in this, the first characteristic is loudness. Then later we discuss about pitch. So what is loudness? Loudness gives the intensity of the sound. See, when I speak like this, hello, good morning, this is soft sound. Hello, good morning, this is louder sound. So I have increased the intensity of the sound. In turn, I can say I increase the strength of the sound. So that intensity, strength is also called loudness. So how can we physically identify this loudness? That is possible by another property called amplitude. Amplitude. What is amplitude means? I will explain it. See here. Before going to the sound production, I will take you another type of instrument called simple pendulum. Simple pendulum. The simple pendulum is nothing but take a metal bob, a small plastic ball also you can take, but metal bob is a preferable one. So metal bob or metal ball you take, tie the metal bob with a string and connect to the support. Now just hold the bob, just pull the bob to small angle and release it. Then what happens? The bob starts oscillating. It oscillates. Then when it is not oscillating, when it is a rest state, then that position is called mean position. It's called mean, means bob is at rest or pendulum is at rest. When it starts vibrating, so this bob goes to the maximum point here only, and after that it is coming back. And the other side also it goes to the same distance to other side and again comes back. So these points are called extreme positions. Extreme. So mean position, extreme position, extreme position. And the distance between mean to extreme position is what called amplitude. So this is also amplitude, this is also amplitude. Both are same, but only the directions differ. It is going towards right side, it is going towards left side, but the distance is same. So the distance between mean and extreme is called amplitude. So more the distance between the mean and extreme, more the amplitude. More the amplitude, more the loudness. So let me take you to the object which produces sound. Again, go back to the simple object as already discussed. Take a table, take a hexa scale and put a heavy weight object which is supported. It make the hexa to support the one side, the other side is free. Now when you hit the hexa with your finger, applying little force, then what happens? The hexa starts vibrating like this. Already this example we have used to understand the vibration of the particle, vibration of the body in the first concept. So when you hit the hexa, the free end, it starts moving. You can see the physical eye also. Now before hitting, the hexa is at rest state, so this is called mean position. After hitting, the hexa is vibrating. It goes to this end to this end, and these are called extreme, like how the bobs are oscillating. So now the distance between extreme to mean position called amplitude. So if you increase the amplitude, the loudness also increases. Both are directly proportional. So in that way, when you are producing soft sound, hard sound, actually you are changing the amplitudes. In that way, you are differentiating the loudnesses also. These loudnesses can be calibrated, can be analyzed using some electronic devices too. These electronic devices show some graphs. With the graphs, a scientific person scientifically understand that how much of intensity or how much of amplitude sound you have produced. Let me show those graphs to you. Those graphs we call sine graphs or cos graphs. So if I say loud sound, then the loud sound will be like this. See carefully. The loud sound will be like this. If you observe these waves, the distance between this end to this end is what called amplitude. More amplitude, louder sound. Now, if I draw the same graph like this is also sound wave or sound graph, but see, this distance is very small. This is also amplitude, but this amplitude is very small compared to this. This is called soft sound. So soft sounds have lesser amplitudes. Louder sounds have larger amplitudes. Now the second property, pitch. Pitch actually decides the difference of sound between men and women. So men have different types of sound, women have different types of sound. If you see, generally women have high pitch sound, men have low pitch, but men have louder sound, women have soft sound. Right, now what is pitch means? So pitch is nothing but it's a frequency which is very high. When the sound is produced, take this example once again. When you hit the free end of the hexa, it starts vibrating. How many times it vibrates in 1 second is what called frequency, is what called pitch. Suppose using some method like using say microscope or using some electronic device connected to it, you have counted the number of vibrations in 1 second, and you have found that it is vibrating 20 times in a second. Then you can say the vibration of the hexa is 20 hertz. Hertz is the unit of frequency and frequency symbol is F. So now you understand, you are saying that in 1 second it is vibrating 20 times. That is the frequency of the hexa. Now again you hit the free end of the hexa with a little more force. Then what happens? The vibrations speeds up. When the vibrations speed up, again using the same technology, you find the number of vibrations, and supposing that you found that it is vibrating. See, vibration means you are counting from extreme to extreme, not mean to extreme. Clear? From extreme to extreme you are counting. So those vibrations, you found that it is 35 times per second. Then the frequency is 35 hertz. Right? Now if you compare the two things, the two values, this is 20 hertz, this is 35 hertz. Both are frequencies only, both are pitch we can say, but we can say it is high pitch, that is low pitch, because less frequency and this is high frequency. So high frequency values are called pitch or high pitch. So now we understand that pitch means high frequency. So in these two cases, 35 Hz is the high frequency sound. Now how would you represent this pitch using graph? Like how you represented loudness using graph. See here. Suppose you want to show the high pitch wave. Then with the same loudness. See this. See, many waves means many vibrations in 1 second. It's only 1 second. This much of intensity, amplitude. Now see this graph. It is also 1 second. What is the difference between them? You have more number of waves, less number of waves. Less number of waves means low pitch. It is low pitch. Same amplitudes. More number of waves in 1 second, high pitch. So graphically, using some electronic devices, we can find that high pitch have more number of waves and low pitch have less number of waves. So we understand that what is loudness and pitch. Now how will you measure the loudness? How could you say that, okay, this is louder sound, this is soft sound, this is harmful to your ears, this is pleasant to your ears. Generally when you are in a car and you are going on a road, and if you observe so many different types of sounds, sometimes you feel that those sounds are not pleasant to your ears, and immediately you close the windows of the car. So why? And how mathematically you can differentiate between a good sound and bad sound, or you can say pleasant sound, unpleasant sound. Yes, physics gives the advantage to you to measure the loudness of the sound also. And that loudness of sound, already I told you, it is called intensity. The loudness is also called intensity. Intensity, theoretically. So the intensity is measured in terms of a unit called decibels. Decibel. The unit of intensity of sound is decibel. In short form, it is shown like dB, small letter D, big letter B, capital letter B. So by knowing the intensity of different sound, we can differentiate that which is good for ears, which is not good for ears. If you see this table, total silence, 0 decibels, no intensity, no sound produced at all. Now if you go from whisper to the firecracker, we observe a whispering, 15 decibels, soft. Normal conversation, 60 decibels. I'm speaking to you, it is 60 decibels, around 60 decibels. A lawnmower, 90 decibels. See, the intensity increased. A car horn, 110 decibels, you can't bear the sound. If you're standing near to the car and one person horn, blow the car horn, immediately you will feel some discomfortable by standing next to him. You may close your ears, because now it is harmful to you, it's paining to your ears. Now you go from jet machine, firecrackers, the intensity keep on increasing. So generally, scientists say that a human being can bear the sound intensity from 60 decibels to 80 decibels. That is permitted. If 80 decibels crosses, then you feel a pain with your ears by listening the sound which is more than 80 decibels. That's why in some moderated cities, they will keep sound sensors in the high traffic region. And they will tell you, or they will put some labels or hoardings, placards that this is the sound intensity you have to produce, like from 40 to 60 or from 60 to 80. Then how a person can know that you have produced 60 decibel or 40 decibels? I told you, sound sensors. They'll keep sound sensors in the circle at the junction of the road. Those sensors detects your intensity and they will display in a digital form in big letters on the road, so that the policeman can easily understand that how much of intense sound you are producing. In that way, we can reduce the sound pollution also. There is another measurement to tell the strength or the powerfulness of the intensity. Like if it is 10 decibels, if it is 10 decibel sound, we can say it is 10 times powerful sound to total silence. If I say 20 decibels, it is 100 times powerful, 100 times powerful to this 10 decibels. If I say 30 decibels, it is 1000 times powerful. If I say 40 decibels, it is, keep on adding the zeros, 10,000 times powerful. So if you see a car and if you hear the car horn, which is 110 decibels, this is how many times powerful? 110 is how many times powerful it is. So 30 decibels is 1000 times. How many 30s are there here? You have, see, 30 plus 30 plus 30 plus 30. So if you take 4 sums of 30 is 120. So around 120 is near to 110. So we can say it is 4 times of more powerful than 30 decibels. So that's why it is very, very powerful sound. You can't hear. You can't bear to hear. Earlier we discussed that we have pleasant sound, we have unpleasant sound. Generally unpleasant sound we call noisy. Pleasant sound, in terms of pleasant sound, is called music. So I told you already, everyone likes music because we feel that that is pleasant to us. And that music makes happy in different situations in our life. And that music, the pleasant sound, in the range of 60 decibels to 80 decibels, that's we can hear. Even though the music is very good music, if the intensity is increased from 80 to 100 to 110, then that even though it's a pleasant good music, your favorite music, you feel that that is noisy. So in one way, noisy we can say the louder sound which you can't bear, that is noisy. Or else you are producing 2 to 3 different sounds, but these 3 different sounds are not in phase, not in tune, then also you call it is noisy. See, in movies, when a song is played, when musical instruments are played, even though different musical instruments give different types of sounds, but all they maintain the same tune. That's why it becomes pleasant to you. You feel very happy by listening to that music. If all the instruments not in tune, different music have different type of sounds productions, then it will become noisy to you. So noisy is either very high intensity sound, noisy is different sounds which are not in a tune. So what is our audible range for human beings? So audible range expressed in terms of frequency. Earlier told in terms of loudness, 60 decibel to 80 decibels. Now according to frequency, what is our range? We can hear the sound, or we can identify the sound, and that range is 20 Hz to 20,000 Hz. In between, what are the frequency you produce? The human being can able to hear, able to detect. Less than 20 Hz, you can't. More than 20,000 Hz, we can't hear. Less than 20 Hz, infrasonics. More than 20,000 Hz are called ultrasonics. And you have many advantages and wide applications using ultrasonics, and that you learn in your next grade. Now, sound pollution. Even though we can say thanks to God that yes, we have got different types of sounds and we are enjoying the sound, but today I am very unhappy to say that these sounds are producing so much of health problems in the way of sound pollution. The sound pollution, what are the causes of sound pollution? The causes are so many, like traffic, different vehicles blowing very louder horns. So these traffic, different vehicles, and huge number of people, the population increasing. Because of population increasing, sound, huge amount of sound is coming out. Industries, machineries. So all these are the causes of producing different types of sounds, and these sounds creating pollution. And because of pollution, again, it is affecting your ear. Suppose there's a big traffic jam and everyone is blowing the horns, then do you think are you able to stand at the traffic jam point? It's not possible. If you stay for a long time, there's a possibility of a bad effect to your ears. Maybe the hearing intensity will be reduced. So sound pollution is very dangerous situation today, and we have to think about to avoid this sound pollution. So what are the different you can say different things so that we can reduce the sound pollution, which can say suggestions. So what are the suggestions you can give for the sound pollutions? See here, what are the suggestions I'm saying to you? Those not be the exact, or those not be the only solutions. You have so many other solutions also. You also think with your innovating mind. So some solutions, like you can, as a responsible citizen, you go to the traffic circles and suggest the person that don't blow the horn with high intensity. Tell them to blow the horn with low intensity, or tell them to use some silences to the part where the sound will come out, so that sound intensity will be decreased. Or any innovative methods you suggest to the industry that create some sound absorbing materials with which vehicles are made, so that even though one vehicle produces sound, the other vehicle absorb it. Not entirely absorbing. Entirely absorbing means you can't hear the sound. That is again dangerous to you. So those absorbing materials such a manner that they can reduce the intensity again. So in that way, we can, like as a responsible citizen, we can extend our support to reduce the sound pollution. So we have understand about what is sound, what are sound properties, what are the intensities of sound which we can feel is a pleasant sound, which we feel the unpleasant sound, what is audible range, etc. Now we will do some exercises based on the sound. Number 1, the to and fro motion of a body is called dash. To and fro motion, like hexa blade. And the hexa blade moving to and fro motion, I use a technical word. Yes, you know that, correct? It is vibration. Now second one, number of vibrations per second is dash. This is we have discussed when I am introduced the word called pitch. So the number of vibrations per second is called frequency. Next question. The intensity of sound can be measured in dash. Means you have to write the unit. It will measured in which unit? Yes, it is measured in decibels. Next one. Sound cannot travel in dash. Cannot travel in without medium. So the without medium is called vacuum. Next. Vibrating bodies produce dash. I think this is a very simple question for you. Vibrating body produce sound. Next one. The maximum displacement of a body from its mean position is called dash. This is we have discussed when I give a small demonstration on the board using pendulum, simple pendulum and hexa. and this is called amplitude. Next one. A normal human beings can listen to sounds with frequency from dash to dash. This is what discussed in audible range situation. So this is nothing but 20 Hz to 20,000 Hz. Next one. How will you differentiate amplitude and frequency? If you ask me, I'll tell you two ways. One is practical way. How will I differentiate amplitude and frequency means if I shout louder, that means the amplitude is more. If I scream, amplitude, okay, there is no differentiation of amplitude, but when I scream, frequency is more. Generally, when woman cries, when woman shouts, then what happened? Her pitch is large, frequency is small. So, when I speak louder, amplitude is more. When I scream, pitch is more. This is a practical example. Now, graphically, if you ask me to tell, this is amplitude. Suppose all these vibrations in 1 second. This is frequency.